Now, listen here. Now, module 3, lesson 2. Or 3, lesson 3. Prove lines are perpendicular. Now, what did we say for the perpendicular line? What do I mean by perpendicular line? As we said yesterday, we have one line and we have another line, and they are intersecting at a right square, which is a 90 degree. We said that the lines could intersect at any angle, like this. But if the angle that is intersected is not 90, we say it's intersecting angles, intersecting lines. But if they are intersected at 90 degree, we call them what? Perpendicular lines. How can I represent the perpendicular? I have to put a square, which means what? This will be 90, or right angle, exactly. Now, where we can find the right angles? Let's see here. Look at this door. Here we have line. Here we have another line. Down here or up here, we have a 90 degree. So this is an example of perpendicular lines. But if you look at this line and the downward, what is the relation between them? Parallel, exactly. Yes, exactly. Here is the same too. This side and the downward. Are they perpendicular? Yes. How can you? From your measure, that's becoming like they are make like square, or you can bring the protractor to measure the angle. Now, here, we said that these are not perpendicular lines. Here, they could intersect at any place, but they would not 90 degrees, so they are not perpendicular lines. Here, they intersected, but not 90 degrees, because as you see here, the line, they could be maybe 70. It's not 90. And here they are parallel lines. Oh, okay. Okay. Here now they are not perpendicular lines. Now, now, how can I represent the perpendicular? If we said that these are two parallel lines, this is AB, this is CD. We said that we're gonna draw, or we can say like this. AB is perpendicular with C. This is what I mean by what? Parallel lines. How can I represent the perpendicular? AB is perpendicular to C. So this sign, it means perpendicular, and this sign, it means what? Parallel. This is what for the perpendicular lines. Now, what are the properties of the perpendicular lines? The properties are, they are always meet or intersect each other. They must intersect each other. And the angle between the intersection, it must be 90 degrees. In this case, we're going to say that they are what? Perpendicular lines. Now, how can I drawing the perpendicular lines using the protractor? Oh. How can we bring the protractor or geometry thing? From here, is flat or not? Come, يلا سني. Okay. طب يلا ادخل. أيوة. Yes, yes. This is for drawing right angles. I want the. It's okay. Mama, I know how can I. No, I can. Yeah, Julie. I know how can I draw, but I want the protractor. But there's something for math. Okay, لا في triangles و compass. This is it. Yes, that's it. خلاص I found it. I found it. F of X math. Sit down. Now, how can we draw it? Let's see. We'll bring this. I know that's a rule. So the first step, we're gonna use what? The ruler to draw right angle. Line. Then after that, I will bring this protractor. I have to put it here in the middle. Okay. Then to start counting from this side. 0, 10, 20, 30, 40, 50, 60, 70, 80. Here is 90. It's okay, but I want to limit them. Why we start from here and from here? Then after that, we're going to remove this. We're going to call the ruler. Hi, ruler. Exactly. We're going to put them like this. Then this one will be what? Now, did you see? They told me that the angle is 81. It's not 90. They're not so accurate. Eh? They measure it. The angle is 81. It's not accurate 90. So sit down now. Okay. So we can just a minute. We can draw these two shapes. Oh. Jury. This for the two. You remember that when you used them before. This is for the two-dimensional shapes. This is for the three-dimensional shapes. How can we draw this one as an example? This one, the compass. This one, we use them for the measuring, for drawing right angles. We can use them, yes, we can say like this. We can draw. We're gonna now measure it if we have perpendicular. It's not accurate, right? Yes. Yeah. Yes, but it's not landed on the line. Yeah, okay. Yeah, let's come back now. Back. Okay, I want to go back. Jury, remove your hand. So this is now how can we draw the perpendicular lines. Now, what is the difference, or what are the differences between the parallel and the perpendicular lines? What do I mean by parallel? They are lines that they do not intersect anywhere. The perpendicular, they intersect and they form a right angle. Examples of the parallel lines, like the steps of straight ladder. The ladder. Yes, teacher Dean. These are what? Ladder. So this we have what? Parallel lines. This line and this line, they are what? Parallel lines. But for the rectangle, you have corner like this, and you will form a 90-degree, which is an example of perpendicular lines. Now, how can I write the symbol? What is the symbol for the parallel? It's like this, and for the perpendicular, it's like this. Now, which of the following objects can represent perpendicular lines in them? Square, shape, tabletop. Your table here. Look at them. Do you have a parallel lines? Yeah. Yes. Yes. And here it's not accurate perpendicular. They didn't make it, by the way, here in the safety, they didn't make it accurate 90. Because remember, it's come like it can harm you. They make it curved in order to make it not you. Yes. So it's what? It's a parallel, perpendicular line. The squares of chessboard. Yes, you know the chessboard? Yes. An oval-shaped mirror. No. Screen of your desktop. And the hands of a clock showing 3 a.m. Here is the clock. Here is the 3. Is it show a right angle? Yes. If all, here now, what do you have? If all the steps in the figure are perpendicular, can you spot the total number of right angles formed in the staircase? Count how many right angles. Yalla, tell me. I will give you now 2 minutes. Count how many right angles we have. Right angles like this. Like this. How many right angles we have? Yalla, count them. Wait, Julie. Sit. Sit down. I want you to see now. Tell me how many are. One by one. How many one says 4? Ayla, you start thinking? Okay. Muzan. Lara, صح انتي? How many says that they are 4? How many say the other 7? Most of you. Okay. 8. 6. Stop. Let's see. One, 2, 3, 4, 5, 6. So how many right angles we have? 7. Okay. Now, go back to our lesson. Yeah. Now, prove the perpendicular bisector theorem. Now, let's see here. The perpendicular, okay, we know all of these things. Now, if there is two lines, they are perpendicular. And if you put any point on the lines, and then you draw 2 lines from this point to that. What do you call these 2 points here? End points. If we draw now 2 lines from one line from this end point to here, and from the end point to here, they must be equals. They must be equal distance. Each has the same distance, equal distance. I will repeat. If I have any line and there's a perpendicular line like this, okay? If I put any point, it could be here maybe, or down, or any place, and I draw a line from this point to the end point, and another line from this point to the end point. They told me the theorem that if this is 5, this must be 5. Yes, that's not accurate.
But if so you can form this, you should first put the small box of making it nice. So you can form the bisection. Just make it like this or this.
Okay.
Can't forget it. It is very important.
Yes, thank you. If you make it like this, you make one line only. Work with what? With one word. Where is the another line? You must continue to say that these two lines. Now, the second thing. Did you remember that if we have a line and I bisect it? What do I mean bisect? Intersect it and cut it into what? Two equal distance. So that's mean if this is a 3, this will be 3. So here, when I have any like this, when I have any perpendicular line, they will be bisector on AB. If they are bisector, okay, not everywhere. If they are bisector, if I have this and this one have the same distance, when I draw any point like point G and drawing two lines to the end points, they must have the same distance. Or here as an example, 4 and 4, or 5 and 5. But if they are not bisector, what do I mean? If you have them like this, it's perpendicular. But they are okay, they are perpendicular, but are they bisector? Is this no, it's not a bisector. So if we draw them like this, they are not equal. This is 3 and this may be 5. But they will not be perpendicular. It's not perpendicular.
Make it here, make it here. Put it right here.
No. No. Okay, so if this case happen, we must have them, we must say that CD bisects AB. If it's not bisect it, we cannot use this theorem. Is it clear? Okay. Did I record?
Yes.
Now, all of you, please go to your book number 1. No, number 2. Number 1. Sorry, here, number 2. Now, number 2, sorry. Is in the line, in the figure here, is B. Yes. Is. Yalla. Which page? Page 98. Yes, here, in this figure. The question is BD, line segment BD, is perpendicular to AC? Why yes يا أمواج؟ Bravo. Amouage say yes. Why? Let's say why. Because BD bisects AC and AD is equal to CD. And the line, a point from B to the end point are equal. So the line of the distance from any point to the end point are equal. So they are perpendicular. No. So yes, because. Okay, I'll write up. Okay. Because BD bisects AC. So how can say B? How let's go. There's no sign for bisect. So BD bisects AC and the BA is equal to BC. So this is bravo because of the converse. So we said before, if it is bisector, so the distance are equal. In this case, happen, so they will be what? Perpendicular. Oh, yes. Yes. Converse of perpendicular bisector. Bisect means they cut them into two equal. Now, did you need your box for that quiz today? The workbook. By the way, the quiz is so easy. Okay, just open it without studying. What? What do you mean about? Okay, what are the lessons are to do that? Group lines are. الترانزيتيف والريفلكس والسيمتريك والسيجمنت اديشن فوسفيلات. That is all. So now number 3. Find the value of the variable. Here. I want now to find B. If here is 4 and here is 4, so are they equal? Are they bisector? If this case happens, so AB is 6, total of BC. So what's the value of B? So because you know why? Because of that perpendicular calculus. So what the value of R will be?
BD is bisector for AC and for
Without it, what is the name exactly? Yeah, the name of the postulate. Perpendicular bisector theorem. That's what. Because of
but the next one is
because yes, because they are equal distance, they will be bisected. Here, because of the perpendicular, because it's perpendicular, because it's a bisector, they does not be equidistant. Here, they told you that they are perpendicular and they are equidistant, so they have to be bisected. Here, in the number 3, they told you that it's perpendicular from this side. And if this side not written, that means they will not tell you that's perpendicular. Okay? So here, it is perpendicular and it is a bisector. So, of course, the distance from B to the end point must be equal. Here, the number 4 is different. Here, they told you that you have a point and they are equidistant from the end points of the line and it is a perpendicular. Can we say they are bisector? Yes. So, if this is A, this will be what? Summarize as you understand. Do you understand why? Ah, you mean the reason?
Yeah.
If you had this shape and two lines or something, then this means
No?
they have and they are bisector. If they is here and let's say like AB,
Yeah.
B, if AB bisects CD, if this case happens, if they bisected, and if they are perpendicular, so if this case happens, and if they have same length, so they are perpendicular.
I think it is down to like, if you mean if AB bisects CD, it means partial perpendicular.
If it is bisected,
If it
they
is bisected.
okay, and this is from this point
But
to
how
the
do I
end
know if
point.
it's bisected?
If it is here, it is they told you that this is 5 and this 5 is bisected. Bisected, it means that it's by up. So if these two sides are equal, if these the blue lines or the distance from this point to the end point are equal, so that means they are perpendicular. Does it know?
This is
Now here. Now they told me that they are perpendicular. They have an equidistance. So can we conclude that they are it is a bisector? Can we or not? Yes. So if it is yes, so here they B AB is equal to BC. Please. If you please know what you must understand the okay? Algebra word, you must understand. So now, if AB is equal to BC and BD is perpendicular to AC, so that means is AD is to DC. So AD is what? X minus A. So DC 60. How can we solve it now? How can I put A to the other side? Positive 8. Positive 8. So X equal is clear? No, not yet. يلا يا. Now here, AD, the distance. Now, AD, line to element AD is equal to the line segment of DC. وBD is perpendicular to AC. AD is equal to DC. ما it's a bisector. ABD it's perpendicular on AC. Perpendicular on AC. So that means AB is equal to DC. So 4A plus element equals 27. So I'm continuing here. So 4A equals what? 16. Bravo. 4A is 16. So A equals bravo. Divide by 4. Divide by 4. So A equals what? A equals 4. Bravo. Is it clear? Or no? Okay, I will. Okay, Tammy and yes. Now you finished? No, we have to. Now number 10. Yes. So S plus X given A day is some number. S plus 6 equals 3x. Bravo. Minus. Okay. What is in my head? Remove it. 6 equals what? No, why is 3x minus S? 2x equals 2x equals 6. Divide by bravo. But just 2 minutes, okay? بس والله 2 minutes only. So S equals 3. Now number 11. يلا يا أحمد. What happened with you? What happened with you?
يمكن عشان كنت مشارك اليوم عشان هيك
So يلا 6D plus 3. إيه؟ هذا ايش؟ 6. يلا continue. Which one? Number 19. طب how did you finish writing? Continue writing, please. Right, I will not. Okay, يلا يا grade 1. I will not let anyone go out without finish writing. يلا, I will take one by one. يلا يا grade 1. No. I want you now. I don't want to wait. Right now. I want you to write. Yeah, 28 divided by 4. 7. So he is what? 7. Right. خلاص, don't continue. Don't just find the variable.
ليه